Today we are going to look into partial fractions. Previously we have learned how to combine two fractions into one single fraction. For example, 2 over x plus 1 plus 3 over x. So I want to make these two fractions into a single fraction. So what we do, we make the common denominator. So it's going to be 2x plus 3x plus 3 over x plus 1. So in final, it's going to be 5x plus 3 over x plus 1. So what we learned before is we make it two fractions into one single fraction. So now what we are going to do is we are going to represent our single fraction into the partial fractions. Okay? So let's look into an example. Let's say give an example. So 2x minus 13 over 2x plus 1 x minus 3. Okay? So what we do is our first step, we're going to represent this as two linear fractions at the denominator. So it's going to be a over 2x plus 1 plus b over x minus 3. Okay, so if you notice here, the denominator over here is a quadratic, and I make it as a two linear function. I factorize this into two linear functions. So what I can do is, since we have a product of two linear functions, so the first linear function is going to be here plus with the second linear function on the denominator, and the numerator over here, it must be a power less than the denominator. Okay, so since here the denominator is a linear, therefore my numerator is going to be a constant. Therefore, so we're going to find our a and b. We're going to find a and b. So what we're going to do is we're going to multiply the whole function with this denominator. So we're going to multiply the whole function with 2x plus 1 x minus 2 with this. Therefore, on my left hand side it's going to be only 2x minus 13, and on my right hand side it's going to be a x minus 3 plus b 2x plus 1. Okay, so now I got two constants here, so I'm going to find a constant. So what I can do is either we substitute any value of x to form an equation, two linear equation, and then solve for the a, or you substitute a value which can make the constant as a 0. For example, here if I substitute x equal to 3, then 3 minus 3 will be 0. 0 multiplied with a, you get 0. So I can do that also. So it's going to be let your x equal to 3, so that I can eliminate my a. So it's going to be 2, 3 minus 13 is equivalent to a 3 minus 3 plus b 2, 3 plus 1. So this will be 0. Therefore here is negative 7 is equivalent to b7. Therefore your b is equal to negative 1. Second, once I find my b, so now I go for the next alphabet or next constant, which is a. Okay, so in order to find a, I want to eliminate my b. So I can let my x equal to negative half. So I let my b equal to negative half. Therefore it's going to be 2 negative half minus 13 is equal to a negative half minus 3 plus minus negative half plus 1. So this will be 0. So here is going to be negative 14 is equivalent to a negative 7 over 2. Therefore, a is going to be equivalent to 4. So now I can take this two value and substitute over here, where a is equivalent to 4 and b is equivalent to negative 1. So what I can put, I take my negative here and I put here negative. So this is how we can transform our single fraction into partial fractions. What happens if we have more than more than two factors? For example, we have 3 factors. Okay, then here will be a, b, and one more c. Okay. Let's look into another example. So here I gave you a function with 3 linear factors. Okay. Since in denominator we have 3 linear factors, so what we're going to do is we're going to form 3 fractions. So it's going to be x plus x minus 1 plus 2x plus 1. Okay. Since this is a linear, so it's going to be a constant, and another constant. Okay. So now we have to multiply the whole function with the denominator here. So it's going to be 6x squared plus 5x minus 2 is going to be equivalent to a x minus 1 2x plus 1 plus b x 2x plus 1 plus c x minus 1. So now we're going to eliminate one of the variable, two constants. Okay, we're going to eliminate 2 constants. So how we can eliminate 2 constants? By substituting any value. Okay, so one of the most easy value is 0. If I put 0, x equal to 0. So 0 multiply the whole thing is 0 and 0. So I let my x equal to 0. So I let my x equal to 0. Therefore 0, 0. So negative 2 equal to a negative 1, 1. So a is equivalent to 2. Okay, and then I already settled by a. So let's go into another variable. So let x equal to let x equal to 1. So let x equal to 1. Why I put 1? When I put 1, 1 minus 1 is 0. So this will be eliminated. And here 1 minus 1 is 0. So this is eliminated. Okay. So it's going to be 6 plus 5 minus 2 is equivalent to, so 1 minus 1 is 0. So this is eliminated. For b, 1, 2 plus 1 is 3. And c, 1 minus 1 is 0. So we eliminated. So we ignore that. So it's going to be 11, 9 equivalent to b3. So b is equivalent to 3. And for the last constant c, we let x equal to half. Let x equal to negative half. So that here will be eliminated, and here also this is eliminated. So it's going to be 6 negative half squared plus 5 half minus 2 is equivalent to c half, negative half minus 1. Therefore, it's going to be here is going to be negative 3 equivalent to c 3/4. Therefore, C is going to be equal to -4. Okay? So now you can substitute your A is equal to 2, your B equivalent to 3, and your C is equal to -4. Okay, so this will be the transforming a fraction into linear partial fractions where the denominators are linears. Okay, so next we'll look into when the denominators are non-linear. So it can be a quadratic or repeating factor. So later we'll look into that.